So to reinforce a lot of expectations and procedures, that's why I take time and go through these slides with you. I don't think I'll do it every single day of the year because a lot of what's in the slides we're also going to talk about. But this is more for like the absent kids or going back and reviewing what we did on a particular day. So the student learning goal for today is to calculate measures of center and measures of variability. Do you guys remember what qualifies as a measure of center? Anyone have a guess on what a measure of center would be that we talked about already? Median for sure. And anything else? The mean. Those are our two measures of center. Feel free to write that somewhere. I know you don't really have a spot on your notes, but just maybe write that somewhere. Measures of center would be median and mean. Measures of variability, or I prefer to call them measure of spread, are like how spread out your data is, whereas measure of center is like a typical data value. So measures of variability, which we're going to learn about today, would be stuff like IQR, which you probably don't know what that is yet, and MAD, which again, we're learning that part today. These two, hopefully you know or have some experience with. And then you're going to know which are most appropriate for data. The learning target. So this is how you'll know if you met the goal for today. If you can calculate the MAD, mean absolute deviation, the interquartile range, or IQR, mean and median for a set of data. That's the goal for today. I am recording right now. I'll link it in the slide, just like I do for every single day, any kind of teaching. If there's helpful videos that I find, I'll link them in here too.
Attention students and staff. This is
note sheets, keep them in your binder, even when we're done with them. Don't just throw them away. Fill them out as we go. Some of this stuff is more discussion based that you don't need to write down, but you know, just pay attention to your note sheet and make sure you say them. The practice for today is a puzzle piece in Schoology. I can tell you that first hour did not have time for it. Although they did make some mistakes in their calculations, so the lesson just took longer. But hopefully we have some time. If not, it does become homework, just like the one from yesterday was practice. You get 2 attempts automatically. If you use both attempts and you want to get a better score, feel free to email me or tell me while we're in class. I won't always give you a 3rd attempt if I think that you're guessing. And usually the things I look at are like the time spent on it. So don't just guess through it and try to memorize answers, because then I won't give you another attempt. It looks like the quiz, your first quiz, will be tomorrow during class time. And that'll be our first assessment, which, as you know, how much our assessments worth in algebra? 80% of your grade, and we don't have any in the assessment category so far. So whatever score you get, it's really gonna affect your grade. Not that you really need to stress about it that much, but just prepare for it. It's on lesson 1 through 5. Everything is posted in Schoology. Notes, videos, there's no reason you all can't get 100% on it. If you're doing your practice and you're scoring well, then that's a good indication that you're ready for quiz. If not, then you need to look back at those lessons that you're scoring low on. Usually at the beginning of the year, I give you 5 minutes per question, and then I train you to be more like what the ACT and the SAT expect, which is 1 minute per question. All right, in the ACT and SAT, it's somewhere along the lines of 60 minutes for 60 questions. So 1 minute per question. 5 minutes is super long. All right, but I know some of you aren't used to taking time tests. Maybe your teachers have never given you a time math test before. Well, it's important that you get stuff done in a certain amount of time. So that's why I'm going to start you off with about 40 to 45 minutes to do 9 questions tomorrow, but that's gonna be cut down, just so you know. So you need to use your time wisely, because you do not get extra time. Questions on that? All right, I see a lot of you already working on the puzzle piece. You need to take notes as well. I did not give you permission to take out your Chromebooks and start working on your practice. So go ahead and close it. It does save your progress as you go, so you don't need to submit it right now. You have to learn what's going to be on your practice for tonight. So close it. All right. So also there are only like 5 questions usually around that. So there's no reason you can't get it done at home. Like it's not a super long assignment. Anyway, for the warm up, finally, we're getting to it and class is almost halfway over. The very first question, you're telling me if it's true or false. The mean can be found by adding all the numbers in a data set and dividing by the number of numbers in the data set. Is that true or false? All right, it is true. So you should be writing this on your warm up, on the paper that you picked up today where it says warm up. This is true. If you want to make it nicer for you to see later, your mean is your sum of your data divided by your number of values. All right, that's basically what this says, but at least this is nicer to see. What's another word for mean? Average. So they use those interchangeably. No both. All right, if you have headphones in, take them out. Your one warning when I send you to Janelle. 2, the mean of the data in the dot plot is 4. True or false? All right, it is false. How do you figure it out? The mean? Well, it's the sum of your data divided by the number of values that you have. So you should have done the sum of these. So like 1 plus 2 plus 3 plus 3, because 3 has 2 dots. So that means it showed up twice. Plus 4 plus 4 plus 5 plus 6. I'm sure some of you can do that in your head. I say use a calculator. Stop trying to do work in your head. Any job that you have in the future, you'll have your phone in your pocket probably that you can use a calculator. All right. When I proctor the SAT and ACT, the instructions always say that the problems can be done without a calculator, but should they be done without a calculator? No, not when there's a bunch of scholarship money tied to that. So just keep that in mind. Use a calculator. You have my permission. If you don't have a handheld calculator, use desmos.com. All right, so add those numbers up and then divide by the number of values. How many values do I have? 8, good. So count your dots. And then just to show you, so I prefer you practice on your own calculator because you can't use Desmos on your standardized tests. But you should all have a Chromebook then. And then you add it up, just like how I'm doing. I'm sure I could combine some of these, but why do that when I could just type it how it looks on my paper? And then it tells me that the mean is actually 3.5. All right. Questions, comments, concerns? All righty then. So mean of this data is actually 3.5. If you want to write that down, I will. The median of the data set is 9 for the data. True or false? True. Can I just go left, right, left, right? What do I have to make sure about the numbers first? that they're in numerical order, least to greatest, like how do you count? So 1, 4, 5, 9, 10. And now you can do the left, right. There's one number in the middle. Our median is actually 5. Not 9. So this one was false. All right, number 4. The median of the data on the dot plot is 3.5. Only 2 answers. It is true if I remember correctly. I like it when dot plots are like this because then you don't really have to rewrite them out. You can go left, right, left, right, left, right. And so you get a middle number. But since this is an even number of data points, and I remember because I counted earlier, there's 12 dots on here. I have 2 numbers in the middle. What happens when you have 2 numbers in the middle? And what's that called? Taking the average of them, also known as the mean. So yeah, we have a 3 and a 4 in the middle. 3 plus 4 is 7. 7 divided by 2 is, which makes sense. All right, median is 3.5. So questions on the warm-up. So if you got them all right to begin with, great job. You already know how to calculate mean and median. If you didn't, then just make those adjustments. And then hopefully by the end of the lesson, you're calculating mean and median well the first time. Scrolling down. So what does the mean tell you about the data? It tells you the average, which is a typical value of the data set. What does the median tell you about the data? It tells you about the middle of your data, your center of your data, which is also considered like a typical data, whatever your center of your data is. All right, now moving on. So here's what we're going to do. Everyone this time, you can take out your Chromebook and we're going to do a pair deck. I normally would do it team-based, but then we have like a hog log situation. And I don't like that. All right, so everyone participating on their own Chromebook. If yours isn't charged or something, then pair up with someone at your table. Otherwise, go to joinpd.com and enter that code. All right, but we have the heart rates of 8 high school students are listed in beats per minute. What is the interquartile range? Now, we haven't talked about that yet, so let's kind of break it down. Do you guys remember what the range is overall of something? Between what numbers? Good. So the range, like the normal range, would be your maximum minus your minimum. But it says interquartile range. That word should be familiar. What does interquartile mean? And so it's your quarters, basically. So we also call this IQR for short, interquartile range. So kind of like your normal range, it is a subtraction problem. What do you think we're subtracting? Yes. So make sure it's Q3 minus Q1. So that is your formula for IQR. Write that down on your note page somewhere. I think on the back it says, how do you find the IQR? So write IQR equals Q3 minus Q1. We've gone over plenty how to find those, the Q3 and the Q1. So if you don't know, discuss with your group and then have an answer. Right, so remember, I mean, I do get like the results afterward, but you don't, just because you see yours on the screen doesn't mean you need to delete it, okay? It's not like your name is on it unless you write your name on it. So let's see. I think I saw the right answer once, if I remember correctly, and it is 3. Let me check my answer key. So only one person in here got it. That's not good. We need to learn that by the end of this lesson. So interquartile range. What's the formula for that? Is it maximum minus minimum? No, that's just normal range. What's interquartile range, that formula? I told you write it down on your note sheet. Good, Q3 minus Q1. So I was helping you remember it because normal range is a subtraction problem. Interquartile range is also a subtraction problem, but you're subtracting your interquartiles. So identify your Q3 and your Q1. So then interquartile range. When I'm identifying my Q3 and my Q1, what do I need to identify before that? Before that even. The median of the whole thing, which is my middle of your data. Now, can I just go left, right, left, right? What do I always have to do first? Put them in numerical order. I saw some of you guys doing that, but didn't quite get to the final answer. So 72, then 75, what else? All right, always verify that you have all of your data points. So I started out with 8, I should have 8 in my list and it looks good. Now, what is my median? So go left, right. And since I had an even number of data points, I should have 2 in the middle. You can't just go left again and be like, oh, it's 77, right? It doesn't work like that. It's left, right, left, right. I have 2 numbers in the middle. What do I do when there's 2 numbers in the middle? Good. What's the middle of 76 and 77? Good, and you can also verify it with that calculation. So that means, and let me move this somewhere else. So that means that my median is actually not really part of my data set. It's in between 2 numbers of my data set. But what I always say is never ever cross out your median. When you're now finding your Q3, which is the median of your upper half, so don't cross out your median. You go left, right. Again, I have 2 numbers in the middle again. What's the average of 78 and 79? 78.5, good. Feel free to verify that if you want. Add them together, divide them by 2. And then the median of my lower half. So left, right, again, 2 numbers in the middle. What's the average of 75 and 76? 75.5. Sorry, I lost my thing. Sometimes it glitches. There we go. All right, 75.5 is my Q1. So yeah, you need to identify your middle of your entire data set to then find your lower and upper half, and then find the medians of those. So then plug them into your IQR formula. Q3 we said is 78.5. Q1 is 75.5. So my IQR is through. Questions, comments, concerns? All right, let me take a little picture and then we'll move on to the next one. Hopefully you guys were taking notes because guess what? The next question is based on what I just drew. So if you weren't taking notes, then you got to start from scratch. All right, now we have the heart rates of 8 high school students are listed in beats per minute. Again, same data. How many values in the data set are less than 1 between Q1 and the median, between the median and Q3, and greater than Q3? This is not a multiple choice problem. This is a 4-part problem. It's asking you 4 questions. All right, so don't just circle one, have an answer for each question. I'll give you 2 minutes. Yes, that's just because you see. All right, unacceptable. At least pretend like you know what you're doing. You will have a portion of like your unit test be a short answer. And then you know what? That's like half of your unit test score. So putting IDK makes you have like at the highest, like a 75%, even if you get everything else right. So never ever do that. Going. All right, honestly, so far I'm more impressed than I was first hour because I see several correct answers. And the correct answer is 2 for every single answer. And doesn't that make sense? Because what do the quartiles split the data into? Into quarters. Whatever amount that data is, it splits it into 4 even quarters. So if I have 8 data points total, well, guess what? I have 2 in my first quarter, 2 in the middle, or between Q1 and Q2, 2 between Q2 and Q3, and then 2 after Q3. And even if you didn't know that, you could look. We already determined what Q1, Q2, and Q3 are. When it's asking you how many are smaller than Q1, well, 72 and 75 are smaller than 75.5. So that's all I was asking. All right. But good job overall. So next one, and you'll need some guidance on this. Now, I'm going to be honest with you. In all my life, in all my teaching algebra and taking math classes and getting my forensic science degree, I've never in my life have had to calculate the mean absolute deviation. But I have had to be able to use formulas, no matter if I've ever planned to use them or not. So that's what I'm going to focus on with you guys. Question? All right. So we are going to calculate the mean absolute deviation using the same data we just looked at. Here it is again. And this is also on your note sheet. So you'll take notes on your note sheet and you'll display your answers for me when I ask for them. But it is the distance from each value to the mean is what our mean absolute deviation is. You might find it helpful to organize your work by creating a table like this. So first thing that we are going to do is find the mean of our data, which we have not done yet today. Does the data need to be in order to find the mean? No. Do you guys remember how to find the mean? Good. So take, like, I don't know how long it will take you. You should be using a calculator. So take like 30 seconds and figure that out. It's the sum of your values divided by number of values. Now go in here, in your mean. Then your mean should be 76.75. All right, again, we're adding all of these numbers together and then dividing by however many we added, which is how many data values? 8. So I don't know what the sum is off the top of my head, but whatever that is divided by 8. 614, thank you. And then put that in this column. Shouldn't the mean be the same for every single line? All right, and the reason why we're doing that, putting it in every single line, is so we can easily do the next part, which is to measure the deviation from the mean. Deviation is just a fancy word for how far away it is from the mean. All right, so deviation from the mean, it's literally just a subtraction problem, which you can see right here. But remember, does order matter in subtraction? So can I do mean minus data value? No, it has to be data value minus the mean, which is in that order already. So also make sure you're writing this on your paper. 72 minus 76.75 is what? All right, that sounds correct. Earlier, I took people's word for it and they were wrong. So make sure that if you're telling me the answer that you verified it in your calculator. All right, and then you keep doing that. What is 75 minus 76.75? What is it? And it should be negative, right? Yes, it should be. If it's a smaller number minus a bigger number, then it should be negative. Do that for the rest of them. You don't necessarily have to write the subtraction problem over and over again, but I want you to write it for at least the first ones in your notes. So that way you know where these numbers came from. All right, so find the rest and then fill in this column. Should look something like this. Earlier, I relied on my class, to tell me all the subtraction ones and they messed up on some of them, which of course then messed up our final answer. So just verify that you got the same answer that I did. I'm not doing anything crazy, just subtracting the data value minus the mean, which is 76.75. Good, any questions there? All right, now what we are going to do is take the absolute deviation. So absolute value, you guys remember what that is? Or what it does to numbers? All right, so absolute value bars look like this. They're usually around a number or like an expression. So like this is saying take the absolute value of the deviation, which is what we just calculated. So if I have a negative 4.75, what's the absolute value of negative 4.75? Good. So if it's negative, it basically makes whatever number that is positive. So what's the absolute value of negative 1.75? 1.75. What does it do to non-negative numbers? They stay positive. Some kids think they become negative, they don't. So yeah, the absolute value of 4.25 should be 4.25. All right, do that for the rest of them, and then we'll make sure that we are all on the same page for absolute value. The real definition for absolute value is how far something is away from 0. All right, so that makes sense. Like 4 is 4 away from 0. Negative 4 is 4 away from 0. That's why everything becomes positive. All right, but fill in your absolute deviation. Take the absolute value of your entire third column. Don't pack up yet. We still have a little bit more stuff to write.
Good morning, Shadow. Rich, it's a great day to be at Stein. I just wanted to jump on here real quick. Shot here. Thank you guys again for today.
Copy this into your notes. Don't leave without copying it. You have 3 whole
Great
minutes.
job.
This is your ticket out the door.
Thanks again. We appreciate it.